This tutorial is for Gearbox version 2, my asset library for Blender 4.3. It includes this bevel gear set, and I'm going to show you how to put together a bull and pinion bevel gear with an additional pinion rotating on the other side. We'll work on the animation and show you how to do that. Okay, let's get started. I'm going to start totally from fresh. It's more fun that way. Okay, so you should see the bevel gear set up here when you look at your asset browser. You don't have to be in your asset browser. You could actually get this from your, down here, Shift-A menu, bevel gear set. Okay, so one thing I want to talk to before we actually get started, I'm going to, first of all, turn on some screencast keys. And remind you that in your scene properties, we're going to be using precision modeling, which simply means we're going to change the unit scale from 1 meter to 0.001 1,000th of a meter, millimeters, and we set the length to millimeters. All this means is that we're creating gears that are their actual size. That's all we're talking about here. And it is the preferred way of working here with this gear set with my asset library. So, with that said, well, we're not going to dwell into that too much. I talk a little bit. I can argue it or whatever, but that's what we're going to work in. And so I'm going to pull these out so they're available over here. And the way you would get these up is join them, do a geometry join. And that's it. So we get this nice, I think it's nice, pinion gears. Look at them sideways, 90 degrees. And what we're going to do is take this one pinion gear and move it around to the other side. And that's not difficult to do either, because we're going to add another pinion gear. We're going to have to transform it around I have to transform it around the x-axis. I keep joking that I could transform it around the y-axis, but it seems more natural to take it 180 degrees around this axis. And that typically is all you need to do to get these to work, especially with simple miter gears. But you do run into problems which we'll solve that if this is odd, these don't line up. Basically what's happening here is that I'm able to, when I create these gears, to figure out how these need to align. I can design this with a tooth along the x-axis, and I make sure the pinion fits when I throw it on there. But I can't predict how it's going to fit on the other side, especially when it's the number of teeth on the bull. What happens is they can cause the top one to not mesh. So it's easy enough to fix. This only happens when the bull tooth is negative, by the way. I mean, odd. Once they're meshed. So it happens with, basically the problem is this darn bull. So let's fix this real quick. It's fairly easy. And it's always good, I think, to get these meshed and working properly before you truly get going. One thing that is going to happen here is that we can kind of fix this in this transform geometry node, but eventually I'm going to come in here and want to rotate this about the x-axis, right? And quite honestly, we're going to run into some issues because we're going to be rotating the bull down here using a transform geometry node. And we're going to be using a motor to do that. Let's do this. Let's get things working in animation, and then we'll fix this other problem. So I'm going to take another transform geometry node, backspace to clear it, and we'll add it to both of these. Okay, and line them all up. Just we're going to try and be really neat. We know, I know, I'm going to need a lot more space here, but let's work on this thing. So in the gear set, in this asset library, I've got a motor, simple RPM generating motor that you can generate around an axis, and we've got the rotation. We can plug that in directly. Okay, and that gives us, we're going to have a rotating bull gear, and this rotates. If you look at it from the top, it rotates, positive radians around the z-axis. You can invert that if you wanted it, if you desire. I don't care. But so to get this other one going, we can't just plug this directly in here because it needs to be going around the x-axis. Okay, so what we'll do here is take this angle and use, we have angular output here, independent of axis. So we can use in the rotation menu, axis angle to rotation. Put this here. Change this axis to the x-axis and plug that in. So now, and this is all you need if what you had here was a plain old miter gear. So, and by the way, we still have a problem, and I'm going to fix this right away. So when we come back to it, it won't constantly bug us. So if you change the number of teeth on the gears from bolt to miter, or either way, even though they're meshing at the start, they've changed gear ratio, and that makes sense, right? So what we're going to do, we're going to fix that by calculating the ratio, easy enough to do with a math node, right? We're going to divide the driving gear, the bull, by the pinion, number of teeth on the pinion gear, and then doing a multiply on this ratio. And now, perfection. Okay, let's take this back down to plain old miter gear. It's smaller, easier to look at. I'm going to fix this up a little bit. And we're actually kind of done with this lower section. And we know we're going to have to work on this upper section. And that's going to take space, and I'm going to try and make more space in general for this upper section by moving these things over. I know I'm going to be needing either this angle or this rotation. So let's probably this angle. So let's move this up in here. We'll break this. We know we're going to need it. Okay, stop that thing. All right, so let's talk a little bit about how we're going to do this. We have an issue here. And part of it is we've got this rotated 180 degrees. That's correct. We know that if this changes, this isn't going to work. And we've got to rotate it just one more. And quite honestly, and then when we do the rotation, this is around Z, we're going to have to rotate around X. And what I'm going to recommend is just save me and let me work with matrices. You may not be familiar with them, but they really are very convenient. In fact, I use a lot of set position nodes instead of transform geometry nodes, but they're fairly easy to get used to. We're going to do a combined transform and set this to 180. And while, sure, I've done the same thing, but the one thing that I can do with this now is have another transform and use a multiply matrix on it. And now I can rotate this in X. And that's what I want. I can rotate this around this way. I can rotate this around this way. That's exactly what I need to do. Okay, so One thing about this is that I do know that when this is odd, set this to 0 because that almost looked like it meshed. Okay, so this is a reset node. When this is odd, this needs to rotate by a half a tooth. This one needs an additional rotation. This one, we're not going to mess with it too much or at all. So how do we get there for this one? Let's first start with just getting this working for this. How do we get this rotate? If we were just going to use a straight rotation in an X, we could simply apply this rotation. Can this work? Okay. The problem here is obviously when we change this, we've got a slightly different setup. This gets shifted by a small amount. It's actually the one thing we can do here is take this angle and add to it before we make this rotation. So we know we're going to need another one of these, right? But the way we're going to add this, we have to do this with a switch because it depends on this bull teeth number of teeth on the bull. So let's get this figured out. We can do that by first of all, the one thing about this angle, obviously, is it's going to be the same as the other pinion because these pinions are both the same. We don't have to worry about ratios. We just have to simply worry about bull teeth. So let's get a math node out. Actually, let's do this. These are new in version 4. Integer nodes. We're going to do a modulo of the bull teeth of 2. And that's going to yield a 0, 1 value. We could use this directly into a switch. I have a preference early on when I'm playing with this. I just prefer a compare just because it is exactly what I'm thinking of instead of, oh, that's a 0 or 1. This is easier for me. And call me a wuss, a math wuss, but I just need to think this way. So when this is equal to 0, it's even and doesn't need to be switched. That's going to be our true value for a float for this. We're going to be able to plug this directly into true, right? So when it's even, we have this true angle, and we can just plug this in. And that means when it's true, it should align. For the false part of that, we need to add a half-tooth rotation. And that half-tooth rotation comes from the pinion teeth. We're going to rotate this around the x-axis, an additional half-tooth. So we have to calculate what is the size of a tooth here. And actually, it's easier than you think. Another math node. We're going to take a divide. We've got pinion teeth that we're going to divide into 2 pi. The circumference of a circle, radians for a circle. And that keyword is tau, 2 pi. And we're going to divide I don't want this to sit in there like that. I'm going to divide, actually, well, okay. I'm going to divide this by 2. That's why I'm messing around here. 2. And that's the additional turn we need to make. Okay, let's just get this out of the way. And I know this is 2 pi. This is dividing it by 2. This could just be pi, but it's just like doing a compare off to the side of a modulo 2. Right now, at this stage, I can optimize this later, but for right now, readability, this is what I need. Just forgive my math wussiness. Okay, and we're going to add this to this value for the false side of this. So that's going to give us this rotation, just that little bit of addition. We could have subtracted on this guy to do this properly. I'm going to move this back so it doesn't look so wonky here. Yeah. Let's do this. So things stay more organized here. Prettier, nicer. I should see if this works even. Yes, of course it works. Math, it's amazing. So now no matter what size, it works correctly. So, and this is it. Because we have the same size pinions on both sides, we didn't create a new pinion, which there's a reason why I do a set. It's because when you, I may have explained this in the intro, when you've just got two gears, when you change, let's make this lower, and this, watch as this increases in size, this cone here gets narrower and narrower and narrower. And you can't just create one without the other. This is a totally different gear, even though it's the same, it's rotating along here and working. It doesn't work. You can't just create a gear and say, oh, I'll just fit this with another gear ratio that's not designed to take this 8:21 gear ratio. It just doesn't work like that. So I think I had this the other way for the image, but smaller bowl. Okay, let's move on, because I think actually think this is it, right? And so we've got this set up. Odd tooth, it still meshes, yes. And the only finesse thing I'd want to do here is add a normal smooth by angle, ignore sharpness. 45 degrees seems to work really well for me. And that's it. Okay, so that's our entire node tree for getting this done. See how much space I need? And anyway, I hope you enjoyed this. I hope you didn't mind getting a little bit into matrices. We didn't do too badly here. It can be daunting. Matrices can, but they're not that bad. Once you get used to them, it's kind of fun. Being able to take this sort of thing and make it work properly in a transform geometry node is kind of nice. And you can see how simple it makes it for the basic miter gear or basic bevel gear set. Anyway, that's it for now. Thanks.